I'm going to show some examples of finding lateral area and surface area of pyramids and cones. And so for pyramids, the formula for lateral area, which is all the triangles around the sides of a pyramid, is 1/2 P times L, where P is the perimeter of the base and L is what's called the slant height. I'll show that in a moment. Now, as far as surface area, pyramids have one base as opposed to prisms, which have a top and a bottom. So to get the surface area, you do the lateral area, 1/2 PL, plus the one base. Now for a cone, the lateral area is pi times the radius of the cone times the slant height, which is the length along the side of the cone. And then, again, cones just have one circle, not two as a cylinder would. So surface area is pi r L, which is the lateral area, plus the one circle on the bottom, pi r squared. Now as far as this vocabulary for slant height, I want to draw a little bit of a distinction here. Here we have a square pyramid. Hopefully you get a little bit of a perspective here. Now, these green edges here are called lateral edges. Those are lateral edges. Now, a slant height would be this distance here, which goes along the face, and basically it represents the height of one of these outer triangles. Now, later on, we'll deal with volume of these things, and we'll have altitude, and altitude goes from the vertex at the top and makes a right angle here. And so you've got your slant height, which is what we're concerned with for lateral area and surface area. You've got your height, or your altitude, which is for volume, and these lateral edges, which don't really help too much. And I put in these things called Pythagorean connectors to give you the idea that you can relate these pieces to each other by using the Pythagorean theorem and looking at these different right triangles. So now let's take a look at some examples. First we'll do cones. They're a little bit easier. Just they come in fewer shapes. They've always got that circular bottom. So I'm going to do surface area, not just lateral area, because that takes care of both really. So we have pi r L is our lateral area plus pi r squared gives us our surface area overall. And so that's going to be pi times 2 times, oh, we don't have the lateral, the slant height yet. Slant height's going to be along here, and so to get that, we got to do 2 squared plus 10 squared is equal to L squared. Use the Pythagorean theorem, so that's 104 is L squared, so L is the square root of 104. So it's pi times 2 times rad 104 plus pi times 2 squared, and that would be in meters squared. Now, for surface area here, again, it's going to be pi RL plus pi r squared. And if this is 3, this is 4. Pythagorean theorem, 3 squared plus 4 squared is equal to c squared. It's going to be 5. It's 3, 4, 5 right triangle. So we've got pi times 4 times 5 plus pi times 4 squared. So that's equal to 36 pi centimeters squared for our surface area. Let's try one more over here. If the diameter is 24, that means the radius is 12. Again, you need to get the slant height. It's a 5, 12, 13 right triangle. If you don't remember that, do 5 squared plus 12 squared equals c squared, and then you solve it for 13. So we've got pi times radius times slant height plus pi times radius squared, and that'll all be in inches squared. So I'll need a calculator to do all of that. Okay. A couple pyramids. Let's start with this. Yeah, do this one over here. So we have 1/2 perimeter times slant height plus the base. All right, 1/2. Now the perimeter is going to be 4 times 12 because it's a square. Each side's 12, and the slant height we don't know yet. So to get the slant height, let's draw in the slant height here. If this is 12 across, that makes this equal to 6. And so we have 6 squared plus 15 squared is equal to L squared. 6 squared, here's 15, equals L squared. So that's 36 and 225, which is equal to 261 is L squared. So that means that L is the square root of 261. So I'll go ahead and put rad 261 right there. And then you've got to add to it the base to get the surface area. The base is a square, which is just going to be 12 times 12. So that entire thing is your surface area. So 1/2 times your perimeter, 4 times the length of each side, and the slant height we got from the Pythagorean theorem with this triangle here and then plus the base, 12 times 12. Now, of course, we can get pyramids in all sorts of different shapes. So we'll do one more square pyramid, then we'll look at a different one. So surface area again, half PL plus the base. Once again, we don't know the slant height, so let's draw it in. Sometimes you're given it, sometimes you're not. This is going to be 2.5, and so this will be our slant height. So we've got 2.5 squared plus 12 squared is equal to L squared. So we'll have 1/2. The perimeter is going to be 4 times 5, because there's 4 sides around the square, times whatever L is. So you need a calculator, solve that for L, and then plus the base, which is 25, because it's 5 times 5. So find out L, plug it in, and then that is all going to be in meters squared. Now here's an example of a pyramid which is a different shape. So here we have a hexagonal pyramid. Okay, I've given you the slant height. You don't have to find that, but it's a little bit trickier. So what we can do is go ahead and find the perimeter, 6 times 8, because there's 6 sides along the base. And then we have the lateral area is half times perimeter times slant height. Perimeter is 48. Slant height, as you can see, is 13. So half times 48 times 13. Now what we need to do is get the base. Now the base is a hexagon, so here's the whole thing done out. You draw the base, you've got a hexagon. You split it by using an apothem and a radius. There's 12 of these triangles, because there's 2 triangles per side, so you divide by 360 by 12 to get 30. Half of 8 makes this 4. To go from the 30 side to a 60, you multiply by rad 3. So, given that figure, if we want to find the area of the base, there are 12 of these triangles. Each triangle is a half times 4 times 4 rad 3, half times base times height, and this comes out to 96 rad 3. So the overall surface area then is going to be the lateral area plus the base, which is all of this stuff plus all this, and whatever that comes out to. And the units are not given here, so you could leave this unitless. If it was, say, meters, you'd want to put meters squared since it's an area.